Hello and welcome to your mod spotlight over Kerbal Operating System, or KOS. This mod was originally developed by Nivik and is now being maintained by Aaron Drake, and it adds the basic functionality of being able to program your own computers in flight and being able to run those programs to make your ships do things. And I'm going to demonstrate a little bit of how to do this. I'm not going to go too much into the code. I will create other videos that detail a little bit more on the code, and I hope that they'll be able to explain it if you actually want to get into this mod pretty deeply and code more advanced than just some of the basic stuff I will be showing. So anyhow, let's get started. In the VAB, you'll notice only two new parts after installing this mod. The first being the CX4181 scriptable control system, which is basically the 1.25 meter part for KOS. And also the KR2042B scriptable control system, which is the 0.65 sized, 0.625 sized part. So you have a part for small probes, and you also have a part that fits better in for larger vessels. And of course, these will both do the exact same thing, it just really depends on which stylistic size you want. Now in the VAB, they have pretty much nothing you can do to them, aside from this one having a light, which you can change that up. And you can change the name tags, which name tags are an aspect of KOS that basically lets you name parts. So if I wanted to say that this piece itself was named something, we can just call this the AI, and you can push accept, and you can actually call that by referencing the name tag in KOS Kerbal script. You can reference the name tag AI to call on this specific part, or if you call more than one part the same name, such as if both of them were called AI, then I can reference both of these parts by just saying AI. Of course, if I say get the name tag AI, it'll give me a list of two parts, which is both of these. Name tags can be very useful if you have multiple engines, such as say you had 4 engines on the side and you wanted to reference each of them. Then you can just name them all engine, and when you reference the list of parts named engine, then it will return all 4 engines and you can tell the engines to do something. This could be especially useful in VTOLs if you have 4 lift engines and say one engine that was tilted on the back meant to actually push the thing. You can reference the engines differently without having to reference only throttle of the vessel, which would turn all engines on. So now that we're out here on the VAB, there's a couple ways we can actually open this up. First would be just right-clicking the part and saying Open Terminal, which we will get the KOS terminal over here. And the other method is going to the KOS tab on the stock toolbar, and it'll open up here, and you can push this button to invoke the terminal. Now of course, this will not just give you one vessel. If you have multiple vessels, it will tell you the name of the vessel, it will tell you the name of the part on the vessel if you have multiple, and of course you can open up terminals from other vessels, and you can actually run programs from other vessels as long as they're within load range. So I'll show this a bit later, but if I had a rover over there and I told it to move, I could move it simply by sitting here on the launch pad with this rocket, because I was able to open up the terminal and give it a command. But like I said, we'll see that after we try out this launch. Now the terminal lets you write certain things, so let me close this first. So you can just basically ask it certain things like print, which is the command to print something to the line. Let's say whatever the altitude is. And the altitude is 93, which if we look here, our altitude is in fact 93. So we can tell it to print out various things, such as print velocity. Now it'll tell us the orbital velocity and the surface velocity. Well, let's try this again. Velocity, surface, I have to type out the whole thing. Then we are getting a vector, which is just v and then the 3 angle magnitudes. So our surface velocity is pretty much nothing, as it turns out. Probably just picking it up from the stresses of the launch clamps is why they're very minimal. But this one's 0.02 and this one's negative 1.43 to the negative 5 power. But you can just tell it to do simple things, like we can say toggle SAS, and as you see, the SAS turned on, and we can toggle it off. We can toggle RCS if we want. Now the terminal just is one line direct code. Basically it works the same way as editing a program in here, but you can tell it to do simple things. So now that I've shown we can do a couple things, how about we try to fly this vessel, see if we can get it to orbit by just running off the terminal. So I'll keep the terminal selected. If you unselect it, it minimizes, but I'm just going to keep it selected this entire time. So what's the first thing we know about rockets? Well, we need to lock the steering to up. So there, now our steering is locked to up. Now we need to lock throttle to 1. Now throttle is a 0 to 1 scalar, so it's percentage based. So if you have 1,000 kilonewtons max thrust, then 1 would be 1,000, 0.8 would be 800, and it locks the throttle to the percentage between 0 and 1. So we locked our throttle to 1, and if you noticed, it changed. And now I believe the last thing we just need to do is tell it to stage. There we go. Now, you notice that the rocket turned around, and that's because I never told it what angle it's looking up. I've told it to lock its steering to up. However, up is just told that way. It doesn't tell it which orientation or roll this rocket needs to have. So I do want to point out that I'm not controlling this rocket at all. This rocket is solely being controlled by the terminal, where it's trying to lock its steering to up, so it's constantly wanting to face up or away from the gravity, and it has its throttle locked to 1. Now it looks like we're going to have to actually adjust our heading before we stage. So I'm going to tell it to lock its steering to a heading of 90 degrees, which is due east, and I'm going to tell it to do that at 60 degrees above the horizon. So right now you'll notice that we're adjusting our heading to accommodate for the gravitational turn. And I'm just going to pull this back up and now tell it 45 degrees just to continue adjusting, and then stage. Now at this point in the launch I was attempting to do a condition where I was saying wait until our apoapsis is at a certain level and then of course cut the throttle. However, the throttle immediately cut because our apoapsis was already greater than the number I had set, and then I tried to set more variables that were supposed to be waiting until. However, it ultimately does not work out, and this rocket I can't really get control of anymore. Some kind of bug locked me out eventually from the commands, probably me just giving it some invalid argument that caused it to mess up. So I'm just going to skip ahead from this launch. You saw us do the beginning part, so it worked out pretty well. We're going to move on to the code that does end up working out much better, where we actually script this thing instead of having to type it in line by line. Now it's all well and good to be able to control the vessel directly by just typing here into the terminal and telling it what to do when. But there is a way to actually script this into a file that you can run anytime on any vessel. And to do that you have to tell it to edit, and then what the file name is. This time it's going to be test flight, with a period at the end, and it will bring you up this, the test flight of whatever it is that you're going to be editing. Now as you can see, if I type in list, then volume number 1, which is the one we're on, local volume, and there's nothing here. Now when I push save, what happens is it actually creates the file once you've told it to save. So testflight.kerbal script is a file size of 0, and this is where the file size becomes important, because like I said, this thing has 10,000 disk space. Once you're using all 10,000, you can't put any more files on this, so it is possible that you might need more than one scriptable control system to operate very large vehicles or stations that have a lot of programs that run them. So how about I type something up real quick, go over what it's supposed to do, and see if it can get us to orbit. Alright, so I've gone ahead and written a quick script that's going to hopefully get us to orbit, assuming there are not any bugs. Basically, what it says is when I run this script, it's going to launch the vessel. And I just noticed I need to tell it to stage. So it's going to print launching, it's going to set its throttle to 1 and set the steering to the heading of 90-90. What 90-90 is means it's going to assume it's going to basically point east with 90 degrees up, which means it's going to point straight up. However, the bottom, the belly of the vessel, is going to be pointing east. That's basically what that's saying. That's just going to help with the gravity turn later on. Then I'm going to say, because we know this first stage will get us to 10,000, wait until the apoapsis is 10,000, then lock your steering to east by 45, which means we're just going to angle down 45 degrees. Wait until the stage's liquid fuel is less than 1. Print staging to make sure we've actually gotten to this point. Wait until our apoapsis is above 100,000. Once that happens, set the throttle to nothing. Lock the steering to 90-0, so we'll be pointing straight east, perfectly flat and ready to orbit. Print our apoapsis, or print apoapsis appropriate, waiting to circularize, which is what we are waiting for. Trying to make the camera so the background's on the green so it's easier to see. Then, wait until the ETA apoapsis is less than 15 seconds. So when our apoapsis is 15 seconds away, lock the throttle to 1, say you're circularizing. Wait until the periapsis is greater than 100,000. Once that happens, lock the throttle to 0 and tell us you're done. So we're going to save that. We can close out and see if this will work. So here I've switched to the actual launch, and the reason I did that is because part of the code was saying that when the stage liquid fuel is just about 0 stage, well, for some reason stage liquid fuel was always returning a 0 to me. So I did a little debugging on that and decided just to go with vessel liquid fuel. But I'm thinking stage liquid fuel isn't working because I'm using a modded decoupler. I'll have to kind of explore that. So just be warned, if you do use stage liquid fuel, it may return a 0 constantly. So try to use stock decouplers. I know it might not even be the decouplers, but I'm assuming it is, because that's usually what separates the stages, in the code anyway. Well, it is physically what separates the stages, but I think you get what I'm trying to say. Anyhow, I do want to mention I have not been controlling this vessel at all. It's been doing everything by itself, staging, firing its engines, stopped its periapsis when it was just about at 100, and now when we're just about there, if you look at Kerbal Engineer, 15 seconds, our engine fired again, and it's going to continue firing. And this is where another one of the problems just kind of slowly shows itself using KOS when you don't 100% figure out all of the issues with actually doing these maneuvers. So we did manage to almost get into orbit. The only issue was that I'm telling it to wait until its apoapsis is exactly equal, or its periapsis was exactly equal to its apoapsis, which never happened. We can optimize that code, and I am going to do a different tutorial video where I optimize this launch code where it will work for any vessel, not just this one. Because if you think of a vessel where its first stage is significantly shorter than this one stage, where it cannot start turning before it stages, then this code would never work. But I'll create code that will work for any launch vessel and probably have it available for you guys to use. But yeah, you can use script to completely script a launch into orbit. You can even do it for getting to things like the moon, other planets, as long as you know what you need to look for and what you need to check to make sure your flight windows are opportune. Anyhow, let's look at some other stuff we can do with this mod. So here I've got a plane with some autopilot script that I kind of showed off in a different video, but I'm reusing it because it's interesting. Now I want you to pay attention to what the plane actually does while I talk about being able to access terminals from other vessels. So just pay attention to some of the text that'll appear as well. Now I am controlling the vessel. As long as this red line is pointing at my target, I am not controlling the vessel. So let's try this again. There, the new target was found. Of course, the gear's deployed again, because this is meant to be fired from launch. Now, here's that thing that I really wanted to show. Let's pull out the terminal from the other thing, switch it to the archive, and then say run test flight. Okay, now ships have this issue where they can't stage unless they're being the controlled ship, meaning pushing spacebar only works if you're controlling that particular ship. So if you note how it won't work right now. Well, that is actually fixable. If you set your engines to action groups, they will run as action groups instead of running as stages. So how about I change that up, bring this plane back in the air, and try that out. Alright, so I'm just going to take control of this plane manually for now, just so that I have a bit more control over how this is going to actually work. So let's try this. Run. There. I just ran the test flight, and would you look at that? If I'm not mistaken, I see a rocket launching. One that we're not actually controlling. We're controlling this plane. Now this rocket is launching all by itself because I set the engine and the launch clamps to an action group. And now we can fly around with that thing very dangerously. Let's see if I can target it. There we go. This will be easier to see. Now here is one of the limitations, which actually, according to some of the 1.0 stuff for KSP, the official release, stuff will be up to 25 kilometers. It will be loaded into physics range. So this might actually work quite a good distance versus right now how I do have to stay pretty close to it. Otherwise, well, if I don't stay too close to it, then it will get out of physics range and of course not be able to work. Although I do not want to get that close to it. Not so close that I hit it, anyway. Now of course we are a plane, so our engine will eventually not be quite as good as that engine. But for the time being we can sort of keep up. Now my main thing is I'm trying to follow this up to 10,000 meters because I want to watch it turn. And it looks like we're going to be able to do that since we are actually at 10,000 right now. Let's watch this thing turn, maybe even stage the second time. Look at that. Our rocket just started turning, and it should stage very soon. There we go. The rocket staged. And now it's successfully going faster than we can manage because, well, we're starting to lose all of our air intake. And eventually it will fly out of physics range and I'm assuming either disappear or, there we go, yeah, it just disappeared because it's still in the atmosphere. Now if it were to have broken out of the atmosphere, then it would have been able to create its own orbit. But we couldn't keep up with it to the point where it actually broke out of the atmosphere, since we're simply just a plane. Now, this is very good, because if you want to launch, say, 5 rockets at once, you can launch 5 rockets at once. If you make them all run the same script, then they will do identical things, meaning that they will very likely not hit each other, assuming you launch them maybe a few hundred meters away, but you can launch multiple at the same time. Well, there is just some of the basic things you can do with KOS. Like I said, I will be posting some other tutorial videos on how to create more complicated programs, kind of like a self-flying plane, as well as a more optimal rocket program that isn't specifically designed for only one type of rocket. And of course, I'll put links to those in the description and maybe annotations. But until then, this has been your Mod Spotlight over KOS. I'm BTT, GRW, signing out.